بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على رسول الله. Welcome to chapter 6, a new chapter, electrical systems. In this chapter, we will learn how to model electrical systems. Okay, we're done with mechanical system. Now we're gonna start electrical systems. Okay, so in this chapter, we will first start with defining what are the basic elements of electrical systems. Remember when we defined a system, what is a system? Any system can be defined as what? As a combination of components acting together or working together to perform a certain task or job, right? So here is electrical systems. In electrical systems, what are the basic elements? They work together. This is what we're gonna study next. And then how to model them, okay, which is the equation of motion or the mathematical model of any electrical system, how to derive that. Okay, this is what we're going to talk next, inshallah. Also, we will talk about electromechanical systems, like the DC motor example. Okay, we're going to talk about that at the end of the chapter, inshallah. All right. Now, before we start defining what are the basic elements of electrical systems, let me take a quick look at electrical systems. This is what I mean by electrical system. You see this circuit or loop? Okay, this is a typical electrical systems. Okay, there are elements inside this loop. What are the elements? Okay, how they work together, how to derive the equation of motion or the mathematical model describing this system, this dynamic system. This is what we're gonna do next. So first, let's get started with defining what are the basic elements of any electrical system. Any electrical system, okay, there must be active elements inside the system, and there must be passive elements, okay, both of them. The active element, when I say active element, this is the source of energy in the system, okay, which is the voltage source or current source. The passive element or passive elements in electrical systems, either resistor, capacitor, or inductor. One of these or all of these three. Okay, we call them passive elements because they consume energy. Okay, they consume energy. All right. So passive element, either resistor, capacitor, or inductor. Active element, either voltage or current source. Okay, let's get started with the resistor. This is how we draw a resistor. You can see that. Okay. Similar to a spring in a mechanical system. All right. Now, what we are interested in, we want to define or find a equation describing the voltage across this resistor. Why we want to find the voltage? Because later, when we model the system or derive the equation of motion of electrical systems, we will use Kirchhoff voltage law. So we need to describe the voltage in each element separately. And later we will use Kirchhoff law, and I will give you an example to make this clear. Okay? So how are we going to derive the voltage across the resistor? From the definition of resistance, which is the voltage across over the current through. Or the resistance, which is a constant for any resistor has a constant called resistance. It's equal to the voltage across the resistor over the current through. Okay? And the capacitor, this is how we draw a capacitor. Okay, how are we going to derive the voltage across the capacitor? From the definition of capacitance. Capacitance is the quantity of charge stored over the voltage across. Okay, okay. So the capacitance, from here, the capacitance, the quantity of charge over voltage. Okay, what is this charge? There is a relationship between the charge and the voltage from here. Okay. And I'm sorry, there is the charge also depending on the current. In fact, the charge is equal to the current dt. So if you want to find the charge, okay, you have to integrate. You have to integrate I dt. Okay, so dq, in other words, dq. If you integrate both, if you derive both sides, dq and here de. This dq, the definition of dq is I dt. There is a relationship between I and the time derivative of the q. Okay, let me show you here clearly although it's not really important. It's not really important. I don't want to confuse you. Okay, it's not really important. This is what you need to remember, this equation. Okay, the derivation and the proof is not important now. Okay, just keep in your mind there is a relationship between the charge and the I, the current. Okay, I equal the time derivative of the current. So if you substitute it back into this equation, okay, you have to integrate both sides and you will get the voltage across the capacitor. Okay, so this is what you need to remember. Okay, this is what you need to remember. Let me write you what you need to remember. This is what you need to remember. Okay, this the voltage across the capacitor, and you need to remember this equation, the voltage across the resistor. Okay, all right. Okay, one more element and we will be done, which is the inductor. You see the inductor? This is how we draw an inductor. How are we going to derive the voltage or find the voltage across the inductor? From the definition of inductance, which is the voltage across over rate change of current through. Okay, so the inductance E over di dt, or the voltage equal to L, the inductance, which is a constant also for a specific inductor. Okay, and this is the equation you need to remember. Okay, as you can see, we want to find or remember what is the voltage across each element, because at the end, when we have electrical system, we need to use Kirchhoff voltage law in order to derive the equation of motion. This is the whole story of this chapter. Okay, all right. What about the voltage source? The voltage source is either this form or this form. What's the difference between the two? When you see E a function of t, this could be anything. It's a variable source. Function, the function of the voltage, variable. Could be anything. Could be step function, could be sinusoidal, could be ramp, could be impulse, could be anything. This is how we draw it usually. And when you see this, I'm sure you've seen this before, and there is a number here. The E is a constant. So this is DC, or constant voltage source. It's not changing with time, okay? It's a constant. All right? And this is how we draw a current source if you have a current source. Most of the time we will have a voltage source. Okay? So this is a quick description of the basic elements of electrical systems. Later, what we're going to do, inshallah, later, is we will talk about modeling electrical systems, inshallah, in the next video. Okay? So thank you very much.